Guys, this is the last video for the course, and we're going to look at binomial theorem here. Now, the binomial theorem, let me go through this. This is a binomial, right? A binomial has two terms, a plus b. That's just a generic binomial. And what we're looking at is we're going to expand these. We're going to bring it to a power, and any power, okay? Well, any positive power. So let's look at this for a second. If I take a plus b to the power of 0, that gives me a 1. A plus b to the power of 1, that's just a plus b. A plus b squared. Well, that means I'm going to take a plus b times a plus b. Now, we've learned a pattern for this, right? A times a is a squared. B times b is b squared. And here in the middle, I've got ab. AB, and I've got AB here plus AB. That gives me 2AB. Cool. That is that thing expanded. Now, what about A plus B cubed? Well, A plus B cubed, I've just got to take this and multiply it times A plus B, right? Okay, so A squared times A is A cubed. A squared times B is A squared B. 2ab times a, so I did the a squared times both those. Okay, yeah, 2ab times a is 2a squared b. I'm just going to start stacking any terms that are alike here. I think I'm going to see a few. 2ab times b is 2ab squared plus. Yep, b squared times a, that's just b squared a, or ab squared. And then b squared times b, that's b cubed. So if I put all that together, put all that together, I'm going to erase a few things here to clean this up a bit. That's gone, and that's gone, and that's gone. Okay, I am going to have a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, I think I can remember that enough. I'm going to erase that all. I'm going to bring it all down because I want this to seem pretty for a second. So I've got a cubed plus 3a squared b plus 3ab squared. There we go, plus b cubed. These are getting a little longer. What about a plus b to the fourth? Wow, yuck. Okay, times a plus b. Okay, a cubed times a, that's a to the fourth. A cubed times b, that's a cubed b. Okay, 3a squared b times a. So I did that times both of them. 3a squared b times a is positive 3a cubed b. 3a squared b is plus 3a squared b squared. Yeah, 3ab squared times a is plus 3a squared b squared. Okay, 3ab squared times b is plus 3ab cubed. Okay, b cubed times a is plus ab cubed. And then b cubed times b is plus b to the fourth. Okay. I think that should do it. Let me erase this, clean it up here. So imagine we're going to keep going. This could be a bit of a pain, but it's possible, right? So this is a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. Cool. Okay. Now, let's erase all this stuff, and we'll talk about it. What patterns? What patterns do you see? Okay. Pause the video for a moment and pick out patterns that you see. Pause the video and pick out patterns you see. Go. Okay, now that you've unpaused the video, Let me pick up some ones that I hope you noticed. Look at this. Power of 0, there's one term. Power of 1, there's 2 terms. Power of 2, there's 3 terms. So the number of terms is always going to be one more than the power, right? Power of 4, there were 1, 2, 3, 4, 5 terms. Also, check these out. The coefficients: 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. They're symmetric, so they're split in half. If you know the first half, you know the second half. It begins and ends in 1, okay? Another huge pattern, check this out. 2, 2, 3, 3, 4, 4. And the other end, 4, 3, 2. Notice this. Powers here, 1 plus 1, which make 2. Here it's 2 plus 1, which make 3. 1 plus 2, which make 3. Here, 3 plus 1, which make 4. 2 plus 2, which make 4. 1 plus 3, which make 4. The powers, it starts with the highest power, ends with that same power, but on the other term. And then the combinations here, look at these. Look. The A's. Sorry, I want to get a different color here. The A's. I've got a squared, a to the first, a to nothing, right? Cubed, 2, 1, nothing. 4, 3, 2, 1, nothing. And then going backwards on the B terms, Check it out. Starts 4, 3, 2, 1, nothing. 3, 2, 1, nothing. 2, 1, nothing. 1, 1. Okay, so the powers of the first term start high and go low. The powers of the second term start low and go high. Yeah. Okay, a lot of patterns here. The more patterns you can recognize in that expansion, the better you're going to be. Okay, so let's look at this. The object of today's game is to expand any power of that here. Okay, now. So actually, let's do this. If I was going to do a plus b to the 5th, let's think about what we would know. We would know it's going to start with an a to the 5th, right? It's going to end with a b to the 5th. And in between, I hope you've recognized it's going to have a 5ab to the 5th, or 5ab something, a4b1. Okay, and if you're like, where the heck did that 5 come from, Dick? Check this out. 1, 2, 3, 4. You see how the coefficient in this second part is the same as the power here? Okay. When we're looking at this, here's row 0, row 1, row 2, row 3, row 4. So row 4 matches up with the 4th power. So think about this. If I did the next one, it's going to go a to the 5th plus 5, and it's going to be a to the 4th b, and then you're going to have an a cubed b squared, because the powers have to add up to 5, right? And it'll be some number there, plus a cubed, so a squared b cubed, plus this will be ab to the 4th, and actually this will be plus 5ab to the 4th, plus b to the 5th, right? 1, 2, 3, 4, 5, 6 terms. And because of that whole symmetry thing we looked at, that's going to have a 5 because it goes to the 5th row or 5th term. And that's going to be 5. And that's going to be 1b to the 5th. So really all I need to know to finish this off is a couple of numbers. And I could have that finished off. Well, let me show you how we can get those numbers. And I'm going to introduce to you, it's called Pascal's triangle. Okay, Pascal's triangle starts with a 1. And then the next row is 1 and 1. In fact, all the rows will start and end with a 1. The next row starts with a 1, ends with a 1, and in between, check this out. 1 plus 1 here is 2. This is what we call the 0th row. This is the first row. This is the second row. Okay. The third row starts with a 1, ends with a 1, but check out the middle. 2 plus 1 is 3. 2 plus 1 is 3. Okay. The next one, 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1. Okay. The next row, 1. Oh, excuse me. I'm sorry. I'm yawning. 5, 10. And if you're not sure where those came from, 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1. Okay. Let's do the second row, third row, fourth row, fifth row. See, row 1, 2, 3, 4, 5. Sixth row, 1, 6. 5 plus 10 is 15. 20, 15, 6, 1. 1, 7, 21, 35. Sorry, I'm getting a little bored of this. That's why I'm yawning maybe. 21, 7, 1. So I could keep going like that forever, right? Cool. It's not that difficult. But check these out. Look at this compared to this. Check it out. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Pascal's triangles will give you the coefficients for a binomial expansion. Cool, huh? Now, you don't have to use Pascal's. You can use this thing. It's called a combinatorial. You've seen it before. You might have seen it like NCR or something like that. Excuse me. So instead of this n over j, this is the same as n choose j. So if I was to evaluate this, this is the same as 3 choose 1. And I'll show you how to enter that in a calculator. But really, you can do it with just the factorials. 3 factorial over 1 factorial times 3 minus 1 factorial. That gives me 3 times 2 times 1 all over 1 times 3. Or 3 minus 1 is 2. So that's just 2 times 1. Right? Right. 2 times 1. Well, the 2's cancel. The 1's cancel, and I get 3 over 1. Well, that's just 3. Okay, now I probably don't do it that way. I'm going to look at this and say, hey, this is the same as 4 choose 2. So what you're looking for in your calculator is a button or a command that looks like this, NCR. On my calculators, they're right on top of the divided by sign. If I hit second, so I can go 4 shift divided by 2, and I get 4C2, like that. And I get 6. Cool. For a moment, find on your calculator 8 choose 7. Okay? Find that. And then do it. 8 choose 7 gives me 8. Okay? Find it. Make sure you can do it. Sorry, I'm yawning again. That's terrible. I'm so sorry, guys. Now, the binomial theorem says that any term in a binomial expansion is equal to this. N choose j over times a to the power of n minus j b to the j. Okay? So, I can actually use this instead of Pascal's triangle to find terms. Okay? Now, I'll be honest. I don't use this much unless I'm finding a specific term. So we'll come back to this. So it does have its uses. Let me show you. Actually, let me show you. We won't come back to it. We'll go right now. Let's look at this. Okay. Let's expand this. A plus, you know what? We already did a plus b to the 5th. So I don't want to do it again. That's dumb. So let's do this. First thing, I'm going to, first thing that I want to do is change the problem. So I don't want to do that one. Let's look at this. Let's look at this. Let's look at like 3x plus 2 to the power of 5. Okay? And we're going to do it two ways, with Pascal's triangle and with the binomial theorem. So binomial theorem says this first term, check it out. This first term, if I do 5 choose 0 times the first thing, which is 3x, and the second thing is 2, this will be 0, and this will be 5. Okay? This number here, the 0, is always here. Okay? And the next term is going to be 5 choose 1, and it's going to be 3x and 2, and the 2 will have a 1 on it, and the 3x will have a 4, because 4 plus 1 will add up to 5. Okay? And so forth. Now, I'm going to show you something for a second. Let's line this up. Let's think about this thing. I'm going to have 6 terms because it's to the power of 5, right? So the first term is going to have a 3x to the power of 5. Next term will have and I'm going to pick out patterns. So it's going to have 5 of those, but it's going to have none of the 2's. Okay, plus the next term, and I'll leave myself some space. The next term is going to have 3x to the power of 4 times 1, 2. See it? 5. 4 plus 1 is 5. Next one is going to be 3 plus 2. So 3x to the power of 3 times 2 to the power of 2. See it? Cool. Okay. Plus, now I'm just going to go 3x to the power of 2, 2 to the power of 1. Cool. Next, we'll have a 3x to the power of 1. Oh, 2 to the power of 3. Yeah. See, 5. Look at the powers of 3x. 5, 4, 3, 2, 1. And then look at the powers of 2. Nothing. 1, 2, 3. This will have a 2 to the 4th. And then last of all, this is going to have a plus 2 to the 5th. Oops, I don't want to do that one. Not yet. Okay. Now, check this out. What I'm missing now is I'm missing the number. I'm going to move that plus sign. Sorry, I want to make sure things are kind of the same. Number and a number. I'll move that plus sign too. Okay, so I'm missing those coefficients, like the 1, 2, 1, things like that. Okay. Well, I know this is going to be a 1, and I know this will be a 1. This I can get by going 5, choose 1. It's always this number here with attached to the 2. So if I do 5, choose 1, or 5 NCR 1, I get 5. Now, if I get one of them, I get another one. Okay, and here it's 5, choose 2, because it's this number here. 5, choose 2, 5, choose 2, I get 10, 10, and 10. And that's it. Okay. Now, that's how I use a binomial expansion to get this. Now, check this out. If I was going to use Pascal's triangle, I would go, okay, 1, 1, 1, 1. I don't memorize this, by the way. I just rebuild it every time. 1, 3, 3, 1, 1, 4, 6, 4, 1. And I want power 5, so I've got roll 1, 2, 3, 4. I need 5. So 1, 5, 10, 10, 5, 1. Okay, so I would look at that and I'd say, okay, there's the 5th row. So I'm going to use that row right there. And my coefficients are going to be 1, 5, 10, 10, 5, 1. I'd write 1, 5, 10, 10, 5, 1. And then I would start out with the first thing, the 3x. And I'd go 3x to the 5th, 3x to the 4th, cubed, squared, 1, nothing. And I'd do the same thing with 2. So I'd fill in the same blanks. So the only difference in expanding this with the binomial formula versus Pascal's is how I get those coefficients. I'll be honest, this is my go-to. That's what I like. But either way is good. Now, I'm not done because I got to simplify all this. Okay, so on this first one, I know this is going to be an x to the fifth, so I just put that there. 1 times 3 to the fifth. I type in my calculator 1 times 3 to the power of 5. Okay, I lied. I didn't really type the 1 because I don't need it, right? And I get 243. Okay, plus, but here I've got 5 times 3 to the fourth times 2. 5 times 3 to the fourth times 2. See, that's what I put in, exactly like that. And it gets me 810. 810. X to the fourth. There we go, plus. Now I've got 10 times 3 cubed, 10 times 3 cubed times 2 squared. Oops. Times 2 squared. See, it's exactly what I type in. And I get 1080 plus 1080 x cubed plus. Now I've got 10 times 3 squared times 2 cubed. Oops. 10 times 3 squared times 10 cubed. 10 cubed. That's not 10 cubed. That's 2 cubed. 10, 3 squared, 2 cubed. Got it. 720. Okay, so plus 720 x squared plus 5 times 3 times 2 to the power of 4 give me 240 x. I just went 5, 3, 2, 4 plus, this isn't a 12, it's 1. 1 times 2 to the fifth, or just 2 to the fifth, gives me 32. There's my binomial expansion. Okay, now that's how we would do it using Pascal's triangle. I'm going to use a binomial theorem. I'm going to use Pascal's triangle because that's my go-to. Okay, so let's look at this. 2x minus 3 to the fourth. Let me show you. Okay, Pascal's triangle. If I'm doing to the power of 4, I need the fourth row. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4. There's my fourth row, 6, 4, 1. So I'm going to have 1, 4, 6, 4, 1. Now, I take the first term, which is 2x, and 2x, 2x. And I'm going to put that in every single thing here. 2x and 2x. Actually, you know what? I'm not going to put it here because check what happens. This goes power 4 to match that, then 3, then 2, then 1, then nothing. And 2x to the nothing is just a 1. So it's not really there anymore. Okay, now I'm going to take the negative 3, and I'll start back here. Negative 3, negative 3, negative 3, and negative 3. Okay, and I start back here with the power of 4, then a power of 3, then a power of 2, then a power of 1, and there we go. Now, let's take a look at this now. 2x to the power of 4. Well, it's going to be something x to the fourth. 2 to the fourth, that's 16. Plus, here I've got 4 times 2 cubed times a negative 3. Whoa, plus a negative. That means this next thing is going to be a negative. So the signs aren't always positive. It depends on those coefficients. This is a negative 96, and it's going to be x cubed because the x is the only variable in there. Okay? So before I do the x things, maybe I should write down the numbers. Positive 6 times 2 squared times a negative 3 squared. It gives me a positive 216. Positive 216, and it's x squared right there. Okay? Positive 4 times 2 to the first times a negative 3 in parentheses cubed times a negative 3 in parentheses cubed gives me negative 216. That's interesting. It's the same thing, but it's going to be x. Yeah. And then positive 1 times negative 3 to the fourth, negative 3 to the fourth is going to be, typed it in, a positive 81. Okay, there it is. So I can use the binomial, I can use Pascal's triangle to look at my coefficients, and then I can just take the first term and bring it to the power that's on the binomial and go down with each term. Take this, sorry, yawning again. Just terrible. Take the second term, go up the other way. Now, that's an awesome way, and I love Pascal's triangle for just expanding it, and I'm always going to go there. However, when I'm finding a single term, like find the coefficient of x to the fifth in the expansion x plus 2 to the 8th. Well, there's a couple ways to do that. I could do exactly what we did before, and I could find the whole x plus 2 to the 8th, and I could just go 1, 2, 3, 4, 5, and circle a fifth term. That's a lot of work. Or I could use the binomial thing that said, hey, this is n choose j, I never remember this, by the way, times a to the power of n minus j times b to the power of j. We could do that. Okay? Now, here's how I kind of think through. I like, when I'm finding a single term, I like using this. Okay? So, and here's where I start. The coefficient of x, see that chair's squeaking. Coefficient of x to the fifth. Well, that means it's going to be x to the fifth. That x to the fifth comes from there. Well, if this x is to the power of 5, the 2 then is to the power of 3, right? Because 5 plus 3 have to make 8. Oh, okay. And then this is going to be 8, choose, 8, choose 3. Because when you're looking at finding the term here, this number here will always be the same as that exponent. So 8, choose 3, 8, choose 3, that gives me 56 times x to the fifth times 2 cubed is 8, and 56 times 8 is 448 x to the fifth. Okay, so if I do it with any other thing, I got to find the whole darn thing, right? Okay, and if I did Pascal's triangle, I got to find the 8th row. That's more than I've done before. I really don't want to do it. Okay, now find the 5th term in this expansion. Now the 5th term is going to have 2y to the power of something. I was going to say 5, but I'm not so sure anymore. For this, I got to use the finger approach. Check this out. The first term is going to have a to the power of 10 in it, right? And then it'll go down. So the first term to the power of 10, power of 9, 8, 7, 6. So this 2y, this is going to be to the power of 6th, and this is going to be power of 4. The reason that happens is, think about it, I have a 0th term there. I've got a 0th line in Pascal's triangle, and I've got a 0th term way over at the end. So this is also going to be, the coefficient is going to be 10, choose 4. Okay? Do not assume that because it's the 5th, 6th, or 7th term that this power here will be 5th, 6th, 7th, or something. It's always going to be one off. So now I got to do this. What's 10 choose 4? 10 choose 4 gives me 210. 2y to the 6th. Well, 2 to the power of 6th is 64. Y to the 6th. And then 3 to the 4th, that's 81, I think. Yep, 81. Okay, equals 210 times 64 times 81. So I multiply those three numbers. I get 1,088,640. and it's going to be y to the power of y to the power 6, y sixths. And there it is. Okay? That would have been kind of a pain with Pascal's triangle, but we could have done it. So let's look at this. Find the sixth term of this. Well, the sixth term, I'm going to have a 1, and I'm going to have a negative 3a squared. Okay, sixth term. Let me think. When it was the fifth term, this was power of 6. So when it's the sixth term, that's power of 7. And 7 plus 2 make a 9. So I think that's right. But I'm going to use my fingers. Sixth term, 9. So I'm going to start with that power of 9 there. 9, 8, 7, 6, 5, 4. Ooh. I was dumb. Oh, because that started with 10, you dummy. Not you, me. See, this is why I use my fingers. I don't trust my brain, but I trust my fingers. Starts with the ninth term, 9, 10, 8, 7, 6, 5. Wait. Okay. Stop. 9, 8, 7, 6, 5, 4. 9, 8, 7, 6, 5, 4. So this is going to be 1 to the power of 4 and negative 3a to the power of 5, since these two things need to add up to 9. And then this out front is going to be 9, choose 6. Okay, 9, choose 6. 9, choose 6 gives me 84. 1 to the power of 4 is just 1. Okay. Negative 3a to the fifth. Well, negative 3 to the power of 5, that's going to be a negative number, and it's going to be a negative 243. And then a squared to the power of 5, when I have a power to a power and multiply them, will give me a to the 10th. Okay? And all is said and done, I've got 84 times 1 times a negative 243 gives me negative 20,412 a to the 10th. And there is my term. Cool, huh? Okay, let's look at a little bit more, and then we're going to call it good. Find the fourth term in this one. Okay, fourth term. So it's going to have a 4x squared and a negative 1, because those are the two terms. Fourth term, use my fingers. 6, 5, 4, 3. There it is, 3. So this 4x squared, this is going to be a power of 3, right? Power 6, 5, 4, 3. There, I can hold up 4 fingers. 6, 5, 4, 3. Yep. And this will be negative 1 to the power of 3, because 3 plus 3 have to add up to the 6th. And this is going to be 6, choose 3, because it's 6, choose that number right there. Okay, so 6, choose 3 gives me 20. 20. 4 thirds, or 4 to the power of 3 gives me 64. So 64, x squared cubed, that's going to be x to the 6th. Because remember, when I have a power to a power, I multiply them. And then negative 1 cubed, that's a negative 1. So if I put that together, 20 times 64 times a negative 1, that gives me negative 1,280. X to the power of 6. And that's it. Cool. Okay. So let's think about this. Find the term that contains m to the 8th. Well, if it's m to the 8th, that means that this second term, well, it's already m squared. So if I square, m squared, 2 times 4 makes 8. So it's going to have to be a negative 5m squared to the power of 4, because this would make a power of 8, right? Well, which means this positive 1 here is to the power of 1. Yeah. Because this is power of 5, and 4 plus 1 makes 5. And this out here will be 5, choose 4. Okay, 5, choose 4. I already know this, but it's 5. I already know it because we've looked at this before. 1 to the first is 1, and negative 5m squared 4 is, well, 5 to the fourth gives me 625, and it's positive. And then m squared fourth makes m to the 8th. If I put all that together, 5 times 1 times 60, 125 make 3,125 m to the power of 8th. M to the power of 8. And that's it. Cool. Bingo. Cool. Okay, now last one. Write an expression to find the term containing m to the 5th in this one. Wow, look at this power of 35. That's why it says do not simplify, because it'll be really freaky big. So I'm going to have 2m to the 5th, because that will make an m to the 5th. Well, this is going to make a negative 3. They have to add up to 35, so this will be power of 30. And over here will be 35, choose 30. And that, by guys, is it. That's all there is to it. Know the patterns. Be able to find single terms. Okay, know that n choose j thing, the combinatorial stuff, so that you don't have to use Pascal's triangle, expand the whole thing to find a single term. Okay, guys, that's it. Practice, practice, practice. That's what's going to get you the secret on all this kind of stuff. And I'll see you next time. Goodbye.